All right, here we go. We're back. We're so back with some rotational dynamics stuff. Okay, this is the next unit of it. Okay. Um, this first part is pretty much all review. Going to go really, really quickly through it. Okay. And so let's take a look at it. So you learned last year in Physics 1 about angular kinematics. You learned how we have translational versions of the quantities and then rotational versions of quantities, and we can learn how to relate those ones. Well, arc length is the length of path traveled by object. Okay, and the units for that are meters. Okay, because it's the distance that the object travels. Okay, angular position is what we call the angle that is subtended. And if you don't know what that means, the word subtended means to stretch beneath. Okay, it's Latin for stretch beneath. Okay, so that's what that means. The angle subtended by the arc, okay, an object travels along. Okay, so if the object's moving, right, here's your arc length right here is s. Okay, here's the angle that's subtended by it, that stretches beneath it. Okay, the equation is s equals r theta, and hopefully you remember that the general form of this, the general idea here, is that we take the translational component. Okay, we take the translational version, we set it, and that is equal to radius. Okay, times the rotational. Okay, so just keep that in mind. Okay, the velocity. So we're talking about velocity now. This is the rate at which things change, right? Rate at which length or position, if that's more helpful for you, changes. Okay, and the units for that are meters per second. Okay. And what's also important to note as well is that you know that velocity is the change in position over the change in time. In physics C, we can call that the derivative of position or the derivative of length in this case. Okay? With respect to time, of course. And then angular velocity, okay, this is the rate at which theta changes. So the rotational, and I'm so sorry, I forgot to mention the units for the angular position. We use radians or rad. You'll hear me refer to as rad. Okay. Okay. Angular velocity is the rate at which theta changes. The units for that are rad per second. Okay, and then you can also define it. This is called omega. I call it omega, right? Because a couple of students gave me that idea last year. But omega is equal to the change in theta over the change in time. Or you can say in physics C, it's the derivative of the angular position with respect to time. Okay. Tangential acceleration, you know what acceleration is. The tangential is what we've been looking at all year up to now. Okay, this is the rate at which the velocity changes. Okay, the units for this are meters per second squared, and then you also know that acceleration is the derivative of velocity. Okay, or it's the change in velocity or change in time. I'm not going to write that whole thing. Oh my gosh, I'm going all over the place right now. This is v r omega. Okay, up there, that equation. Okay, guys, we do the tangential equals radius times the rotational. Okay. Angular acceleration is very similar. This is the rate at which velocity changes. This is the rate at which angular velocity changes. So rate at which omega changes. Okay, and the units for this, very similar, are going to be rad per second squared. Okay, and this, just like before, alpha is equal to the change in omega over the change in time, or the derivative of omega with respect to time. Okay. Okay, and then you have to know how to do your translational rotational equations. How do you translate the translational equations into rotational? Well, it's really easy. Okay, it's not that bad at all. All you got to do is recognize that every translational variable has a rotational analog. So any x's that you see, you would turn those into theta. Any v's that you see, you would turn those into omega. And then any a's that you see, you would turn into alphas. Okay, so that's all you got to do. So I would do theta equals omega t, and time stays the same. Okay, theta not. Okay, v is omega equals alpha t plus omega naught. Okay, this is theta equals 1/2 alpha t plus omega naught t plus theta naught. Okay, and this is omega squared equals 2 alpha theta plus omega naught squared. Okay, so there you go. Okay, that is all of section one. No, section two starts on the next page. Okay, cool. So there you go. All right, girl, boss it up.